I get lost inside my thoughts, and when I start to think, oh, the Tahoe closest starts to end up on the brink. I tried so hard, but all these scars, they cut so deep I bleed. I fell so fast from heaven, it's like someone clipped my wings. Now I'm falling, and I can't see the ground. Can we stop this gravity? It keeps bringing me down. I can't breathe, and I don't wanna die. Can we stop this gravity? 'Cause I don't wanna say goodbye. I forgive the pain you gave to me so long ago. Sleepless nights I laid awake just begging to let go. I almost got to suicidal thoughts, but you stepped in. An angel sent from heaven showed me how to live again. Now I'm falling, and I can't see the ground. Can we stop this gravity? It keeps bringing me down. I can't breathe, and I don't wanna die. Can we stop this gravity? 'Cause I don't wanna say goodbye. Sometimes I have to keep on breathing in. My lungs are filled with too much pain. All the shadows of the past that I'm so leaving, they held me in my sleepless nights. And I'm drowning in the noise like a free fall, walking along my path for too long. All right, hello everybody, welcome back. We are going to do more hacking practice on this stream, continuing with the work that we did last, well, I guess on Monday. Doing stuff with angr. We have one last entry in the angr CTF, and then we can come back to the nightmare course and start working on those CTF challenges, the sort of for real stuff, and to try to use angr to solve them. See if I can apply what I've been practicing from the more tutorial oriented work. So yeah, I think we can just get into it. I've already copied in the necessary file for the last one, 17. And this one is about a jump target that is potentially user controlled, I believe. An unconstrained state occurs when there are too many possible branches from a single instruction. This occurs, among other ways, when the instruction pointer on x86 EIP is completely symbolic, meaning that user input can control the address of code the computer executes. For example, imagine the following pseudo assembly. And I believe this is more in the AT&T style. So move user input into EAX rather than the reverse, and then jump based on the value of jump to wherever EAX points. So in that case, user input is a symbolic value, so EAX is then symbolic, and jumping there could jump to any of 4 billion possible locations. Of course, in practice, that's somewhat constrained. You're only going to be able to jump to pages that are mapped in with the execute permission, but depending on your level of simulation, you might not know which those are. So other than maybe, actually probably jump to 0 is fine, conceptually at least. It's not going to happen on most operating systems. I don't think they'll map in the null page in Linux on x86. I'm not sure. But in any case, the way angr looks at it is it could be any value in EAX. So the value of what the user entered dictates the next instruction. This is an unconstrained state. It wouldn't usually make sense for the execution engine to continue because it doesn't have any, like, one address is more likely than another address, so its only option would be to try to simulate all of the potential addresses, and that is far too much. So yeah, doesn't know where it should jump to. Normally when angr encounters an unconstrained state, it throws it out. In our case, we want to exploit the unconstrained state to jump to a location of our choosing. We will get to how to disable angr's default behavior later. This challenge represents a classic stack-based buffer overflow attack to overwrite the return address and jump to a function that prints good job. Okay, so this is the last example is really the first real exploit in terms of getting control, like having direct power over the control flow, let's say, or controlling execution.
Yeah, so the last two were also exploits, but they were read and write data exploits. I guess the write data could also, depending on like if you have rel-row protection, could result in controlling execution flow, but this is the first one that's definitely RCE, at least as far as the example itself, and maybe could be the most relevant to what we will be doing in the Nightmare challenges. Those might just be crack me style, but they could also be, they could turn out to be something where you need to have an actual pwnable that you saw with angr as well. So our strategy for solving the challenge is as follows. Initialize the simulation and ask angr to record unconstrained states. Step through the simulation until we have found a state where EIP is symbolic. Constrain EIP to equal the address of the print good function. Okay. So that's an interesting approach to it. Basically, once we get to a point where we know that we can control EIP, then we can put our constraint to where we want EIP to be at, and we can I'm also thinking about like how much of this could you automate, but yeah, so we can put a constraint to set EIP to whatever address we want. In this case, we are putting a fixed address of a known location for a function that's in the binary. This is going to rely on the binary not being PIC, and us actually having identified where that function is. If there was NX disabled on this binary, then in theory we could include shellcode in our input, and we could, I'm thinking back to some of the early challenges in the Nightmare course and the very like early versions of the Stack Overflow stuff. When we start having to put shellcode in for challenges that don't involve ROP, we could potentially, when we hit the point where execution is unconstrained, we could look up through the stack until we find the first or some buffer of a certain size that is like symbolic, meaning we have access to control it, and then we could jump to the beginning of that buffer, constrain those values in sequence to be the instructions that we want, and like maybe we could write a script to do that. That would be very interesting to me, if you could effectively pair up angr and pwn tools and have an auto solver, an auto pwn for simple buffer overflow attacks. And you might be able to extend that for ROP-based stuff as well, but I'm probably not gonna try for that on this stream. It just seems like an interesting possibility. I wonder if anybody's actually done that. Zero tool, automatic exploit generation, and remote flag capture for exploitable CTF challenges. So it uses angr to analyze binaries by hooking printf and looking for unconstrained paths. These program states are then weaponized for remote code execution through pwn tools and a series of script tricks. Finally, the payload is tested locally and then submitted. Neat. So I'm going to go ahead and throw a star on this. I mean, it's being updated actively, which is really nice. Yeah, definitely want to look through this code because, and if you're into this stuff, I'd also suggest looking at Zera tool. If you can do this stuff automatically, that would be pretty awesome. They also have one for using a pin tool to solve CTF problems. They got a lot of CTF tools, basically. Nice. Yeah, I should definitely be looking at a lot of the work that they have done, I think, because these seem useful. Easy RE. This is another tool, but more for reversing stuff. I mean, wow, that would be so... I don't know, I feel like if I could go to a CTF and just throw automated tools at stuff and get flags from, you know, pwnables and reversing challenges, that would be pretty amazing. I mean, certainly trying to develop a framework that uses angr to solve all the stuff in the nightmare challenges, or as many of them as possible, would be a good way of like testing and building that library, that framework on top of angr. I'll look at this one as well. So yeah, I mean, I feel like the more manual approach is to use angr to find overflows, but using it to actually, I'm gonna save this. Yeah. Oh, it's by the same guy. Very interesting. Pretty sure it's by the same guy. I think I need to turn off the style. No, doesn't have a hidden link somewhere. So why don't I have a link to the source for it? Well, I can go to like github.com/breakingbits. Would that work? No, I don't think that's... Let's see if there's any... Is this just going to take me to Gitbook? Okay. But yeah, I'm assuming the repo's in here somewhere. Weird. Chris Roberts. Christopher Roberts gave a talk at DEF CON 27. It was 27 last year. Go ahead and subscribe to whatever this is. Yeah. It was last year. I did not see this when I was there last year. Sorry for making this stream my OS intelligence thing. All right. There's more for Red Lattice. Not Chris Hayes. I'll figure it out later if he has a Twitter that I can follow or something. But yeah, his work seems pretty cool. Is this guy? Cool. I mean, seems to have interests that are very interesting to me as well. Okay, so it does sound like there's potential for building on top of angr to do even more involved automation of analysis. But I'm going to continue focusing on the problem that I set forth for myself. So we're going to do 17 and then we're going to go back to nightmare challenges. So I think we're going to start this with entry state. And I'm going to go ahead and analyze it. Okay, and print good is the function that we end up wanting to call. We'll go ahead and throw that in wherever it wants us to fill that in. Let's see. Sure it has it in here somewhere. I guess yeah, all right, let me just put it, oops. Nope, I didn't copy the thing. Okay, then the registers want EIP from it, I'm pretty sure. I don't want to get ahead of myself. The save unconstrained equals true parameter specifies to angr to not throw out unconstrained states. Instead, it will move them to the list called simulation.unconstrained. Okay. Explore will not work for us since the method specified with the find parameter will not be called on an unconstrained state. I see. Instead, we want to explore the binary ourselves. To get started, construct an exit condition to know when we've found a solution. We will later be able to move states from the unconstrained list to the simulation.found list. Alternatively, you can create a Boolean value that serves the same purpose. I don't know why we want to move them to the found stash, but we will hopefully understand by the time we're done reading through the code and comments. We will set this to the exploitable state once we find it. Okay. And I see. So yeah, if it's satisfiable, then that's our solution state. Okay. Let's see. Check if there are still unconstrained states left to check. Okay, so we have a whether or not we have more unconstrained states. So I guess the idea is we might end up with a lot of unconstrained states, and we want to check if for each one of those it is satisfiable to put EIP to add the constraint for EIP. And once we've added that constraint, is the previously unconstrained state now constrained, or rather satisfiable, not necessarily fully constrained? Yeah, so is that the one piece keeping it unconstrained, I guess, is one way to phrase it. So active is the list of all states that can be explored further. Okay. Okay. So, whoops. So, while we have either active states or unconstrained states, and we have not found a solution. Okay, let's see. Oops. I'm going to say if there's more than one thing, and honestly, you could probably say, that's fine. Okay, so for everything in the list of unconstrained states, we'll get the EIP value. We will attempt to add the constraint to see if it's satisfiable with that. And if it is, then that's our solution. So then we add that particular constraint and break. And we will remove everything from unconstrained once we've looped through all of it, or we found a solution which caused us to break from that loop. And then we continue advancing the simulation, so that moves all the active ones forward. Sure that every printed byte. Okay. So for every byte from standard in, we will add a constraint that it be an uppercase letter, and then solve for the user input. Recall that this is POSIX.dumps. Okay, so I mean, shouldn't we be able to just say solution state at POSIX.dumps? We'll decode. Yeah, that seems fine. Okay. It's honestly pretty straightforward, even compared to some of the ones just previous. Extra constraints argument should be a list of constraints. Okay. that. And let's see. I'm not sure if I need to say add constraint or add constraints. Yeah, I guess it is plural. In which case, I think it takes just star args. Has no attribute files. Do it this way. Just changes to the nope. Okay. So we need to look for sim system POSIX. There's just differences in the API from when this was originally written. Is it extending sim state plugin? Oh, I think that's too general. Is there a files? Oh. Yeah, so this has but we need to know the program state might have a file system. FS, that's what it was. Okay. Not files. Or fs.files rather than POSIX.files. Sim file system has no attribute files. What? Just looking at sim file system. Oh, that is a parameter files. Ugh, okay. Could I just say .get? That's a path though. We have file now. Where's dumps? FD. Okay. Closed FDs. Get FD. Looks up the sim file descriptor. I guess we could try that one. Yeah, let's look at get FD. Oops. Then we want POSIX.getFD. Nope. How do we do that then? File descriptor base. So we just say dot read storage or dot write storage. Dot, what do we want to do? I guess we want read storage, right? Because it's standard in. Packet stream, Jesus Christ. We don't even have all bytes anymore. What the heck? Ugh. Too much has changed. Constrain standard in. Let's look at the more generalized documentation. Advanced topics. Don't know if we can actually. Yeah, I mean, maybe there's a way to achieve it at this point, but I don't know what it is anymore. Can we create a file? Can we just not constrain it and see if that happens to work? Okay. Is that enough? Let's see. So the program goes through this read input. Which calls scan. Yeah, that's not long enough, right? It's going to read it into 20H. So let's see. We want to if we get to a point where EIP is unconstrained, that is because with scanf we read in 32 plus probably 40 bytes. Although actually, well, that shouldn't be a problem. Yeah, I mean, we're making a lot more space in the frame, but I don't think it matters. Okay. So that would imply that it scanned in enough. Let's see it just as bytes. Okay. So can we see what we can do with the bytes? I don't want a byte array actually. Bytes objects, class bytes. So is that all we have? We can just say dot hex on it. That seems like maybe too minimal of an interface. We can't search through it reasonably. Wow. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. Right? And then the next 4. Yeah, so that seems like it has put it at the right spot. I see the reason for doing those constraints though, because then it's a printable thing. But what we could do is just write it to a file. And then we can pass it in. So the constraint that was in there was to make sure that all of these what end up being null bytes, because angr's, or rather the like Z3 solver, sort of starts at null, and since these weren't really important to how the program behaved, it just kept them as null. We wanted to put an additional constraint on there to constrain these to be a printable character, basically. But that ended up not being as easy as or at least like the API for it has changed enough that I'm not sure how to do it easily at this point. So we don't really need them to be printable. Like this all null bytes does work because scanf is not caring about null bytes. It's caring about spaces, I think. So we really just needed enough to get to here, and all of this is still overflowing past the end of the buffer, but it doesn't really matter because we jump to the good job function. by interpreting this as the return value. So, okay, that seems, like one way to go about it. Let's see if we can apply that to the challenges that we have here in the Nightmare course. And I'm going to copy these in from what do we have? Do we have a flag file? No. Okay, so most likely this is a reversing challenge. Let's look at the file. It is 64-bit ELF. It is stripped, dynamically linked. It's linked just to libc. And checksec says we've got everything enabled. Okay. It's a well protected binary. I'm guessing that this isn't intended to be ownable then. You do not know to wait. Okay. So the what is the meme? The little guys. I don't know. I don't know if it's reading from don't know where it's going to read from, so let's open it up in Radar. And what are we getting from? So we've got a whole bunch of local variables. It doesn't say anything that implies that it has arguments. So what are we actually comparing here? Local 38, which was Rax, which is from Rax plus 8, so which was from local 50. Oh no, okay, so it is, let's see, so 50, or rather, okay, so I think it does need to be a command line argument. So that's not actually a scenario that we had to deal with angr, but it shouldn't be too difficult. We can start it and set EDI equal to 2 and set RSI equal to a pointer that points at 2 pointers. Yeah. So, rather, RSI will have the address of an array of string pointers, character pointers. Did they quit already? Got the spammer in channel. Okay, so let's see. Yeah. We just need to set up the parameters to main. I wonder if there is actually stuff for doing that. Let's look under entry state maybe. Come on. Last time the searching was too slow to actually use it. Okay. Yeah. So we can put in an argc, or we don't need the argc. We could just put in args. Cool. So let's see. How far I can get with from memory, basically. So we want a state to be proj.factory.entry state of args is going to be equal to a byte, and password is going to be, okay, we need to get the strlen. So if it's not equal to what, 35? So angr dot, how do I get a BVV? Just directly from, do I need to just import clarify? Because I feel like all the solutions, or all the examples that they mentioned in here that had like BVS, BVV, had it on top of a state, and I don't have a state yet. So I'm gonna just say, yeah, you can just import clarify as well. All right, I think we're back. I accidentally switched into OBS, which kills it sometimes. It's kind of like rolling the dice, and I would say majority of the time you lose that dice roll. Okay, so then the password is going to be 23 times 8, because or 23 hex bytes. So that'll be our second arg, and I think oh, that's under clarify. So list of values to use as the program's argv. I mean, I'm gonna go on a limb and say what gets put into the argv when it runs it is actually a set of pointers to these values that have been loaded into the memory state. So I think I can just put the bit vector directly in there. And then you can do, what is the good condition? Okay. think if we say if return oof or to good in state dot posix dot and failure is you do not know the way. Okay, so then simgr is proj.factory.simgr and simgr.explore and let's see what the explore function is. Find and avoid, I believe. Right? Yeah, find and failure. Dot okay, so then if it's found, what we want to do is say print simgr.found 0 dot posix dot dumps sys dot standard out dot standard, or sorry, we want to do simgr.found 0 dot solve solver dot eval password cast2 equals bytes dot decode could not find a solution. All right. So success state is just the one location. What did it say? It's position. Let's see, base. Oof, there's too many, more than 1,000 matches. Project. To say something about where the base is. Nope. Does not have. Why can't I set the base address when it loads? Okay, so I can put it in main options. Put base address in there, okay. So they put a base address of this. I'm gonna stick with that, but I just want to be explicit about it in the code. So main ops, right? No. adder. Okay, then instead of success, we're going to put in base plus 0x880. Still couldn't find it. Okay. So let's do, there was something about how to get into a interactive shell, I think. But just like, where was that actually? Solver engine. I don't think they called it a shell though. Goddamn, I don't remember what they called it. They did mention IPython, I think. Oh, maybe it was under the introduction up here. No. Breakpoints, I think, yeah. Okay. Where was IPython mentioned in here? The action is BP IPython. So what are the actions that can be specified? I don't know that I have. Just call it P. They don't list what the of course not. I mean, yeah, great. Do you have anything in the appendix? Maybe list it? No. So I guess into the code. That just a couple of these. Okay, so what is the like IPython function? I see. Do we have IPython? Pip install IPython. Just go ahead and have it. I don't tend to use IPython, but I guess it's fine. Oops. Yep. Okay, so then I want to set a breakpoint. On instruction, I guess. Maybe on fork. They show. Okay, so I can put a particular instruction address. Let's try that. This is presumably on a particular state. Oh, it's on. Yeah, it's on a state. Okay. Then let's say s.inspect.b instruction. Should be base plus 75C. I don't know if the direct reference there to VPI Python is going to work, but give it a shot. Oh, of course. It is state. Yeah. Angr.bp. Okay. And it didn't hit that. Interesting. Okay, so they were showing a little bit of how to do stuff manually in here, I think. Maybe it was in the solver engine. Maybe it was in top level. Yeah, so Wikipedia entry, okay. Can we so step does a whole basic block. So I'm gonna go ahead and create the simgr. And say simgr.step and simgr.active 0 dot, how did we put it up here? Wonder if I can call block on a state object. Yeah. I think I call preprint down on the block itself. Yep. Okay. So let's see what that looks like. Oh, sure, we'll just exit after that. Okay, so where is all of this? Okay, that none of that is part of the main function, so I need us to run until we find this address, I guess. Right, like if we entry 0 is also not this one. What are these addresses? Oh, this is after maybe we did the call. Whatever. Okay, so let's say maybe rather than explore, run so I guess I will just do explore for right now. So we'll explore until we get to the beginning of main. is at 0x73a. Okay. Oh, maybe I need to use something from the loader. Maybe it's not like base plus that address. Maybe we want I want to find a way to just, given a particular loaded address, which is the text section. Okay, I see. So, oh, but it's still going to be, right? I don't think these addresses are relative to the start of the text section. I think they're probably just relative to, maybe not. Well, let's give that a shot. Let's see if it finds this instruction, base plus 73a, and see if we can find the start of main. We did. Okay, so that is that stuff. So then why can't we step through this block? We're jumping to the NOP because 44, which is EDI, is not 2. Maybe maybe that's the issue. We don't actually need to provide a first parameter. Nope, still gets to that And when we set argc equal to 2, what the heck? Well, before we step, right, we can say simgr dot found 0 dot regs dot edi. And it's 1. Why is it 1? When we create a simgr, does it, maybe we need to pass in that state, I guess. Yeah, okay. So okay, and then we do still need that first parameter. Yeah, okay, so then I think we can get rid of all of this and say find equals success. Hey, there we go. Wow, you know the way. 8H2. I think this is just random. Cool. Okay, so that was, you know, it's a slight modification on what we were doing before. Really, because it's a arguments thing, like we could have done some involved work and set up these registers and set up some memory addresses and made them point to the right things. Like we can set up the entirety of the program state, registers and memory and all of that as needed before we jump into something. Thankfully, the good people that work on angr have created that functionality in an automated fashion if you just pass in an array. And since we know that the parameter, basically the second argument, given that the first one is always the name of the program, in the way that C works at least, the second one is what we need to solve for. So I created a bit vector symbol for it. I was able to see that first they do a string length comparison and make sure that it is that length. So I went ahead and made the bit vector symbol that size. Then our success state was if we printed out the good message. Our failure state was if we printed out the bad message. And then we just explore using those checks until we find one that got to the success state, and then we solve for what the password portion was. Yeah, so cool. I was able to, you know, realistically use the angr stuff to solve that. That wasn't so crazy. The main difficulty was I failed to remember to set up the simgr and pass in the state. And so the state that we were working from when we were stepping the simgr was just like a completely new state, basically. Presumably it was an entry state, but it wasn't one that had the args set up. So unfortunately, because I forgot about that, I had to do a bunch of debugging to get to the point where I could determine that's what was going on. But otherwise the challenge was pretty straightforward considering the way that we solved the stuff in the this set of challenges. So I feel good about that. Let's go ahead and read the walkthrough on this one, and then we'll move on to the next one since we definitely got time. Does stuff. Honestly, who knows? I didn't really look at any of the behavior of the code other than the control flow. So this was actually not a very complicated, it sounds like not a very complicated argument. So it's just this value XORed with 1. So we could absolutely do that manually, I think. Yeah. Oh, the input XORed with 1 is the desired output. So we could do this manually, I'd say, because this is like XOR is the same backwards, right? So if we just XOR 69 with 1, that's an H for HS CTF, right? And then 72 is going to be HS. Yeah. So honestly, creating this, like using Z3 for this, is completely overkill, and certainly using angr is overkill as well. But the nice thing with angr is I didn't even have to worry about understanding what the code did. But if you went to the trouble of copying out that array of bytes, then you can simplify this by not using Z3 at all and just throw in the XOR yourself. And I've certainly solved problems like that before. Okay, because there's no need for a constraint solver with something this straightforward. Next one, Tokyo Western's 2017 Rev. My guess is not going to be quite so simple. Because I think the Tokyo Western's CTF group are very competent. I guess that doesn't necessarily mean that their CTF challenges are more difficult, but that's sort of part of the implication that I would expect a relatively difficult CTF from a team like PPP or what Dragon Sector does and all of that stuff. Folks that have been to DEF CON repeatedly, it sure seems like they would be apt to create more difficult challenges. Okay, so 12 Tokyo. What do we got? Not.py. Well, I don't think that one is important to us. So I'm not going to copy the py files because I think those are part of their solution. Let's look at rev. It's a 32-bit binary. It's dynamically linked and it is stripped. I meant to run it with LED, only using C, and security. It's got no PIE, so that's a little bit, I mean, I guess that would matter if we were trying to pwn it, but I don't think we are, is my guess, with no flag file. Okay, so it takes input. And does fgets. So it is pulling in a 33 byte buffer, and it's going to do some stuff to it, I'm assuming. Then we want it to print out correct. So I think we can use angr for this. Okay, so we want dot rev, and the project, we want to say proj dot factory dot entry state, and I think this one can be super simple, right? Simgr is proj.factory.simgr from the state, and then success function correct in state.posix dumps oops didn't want that as a string. Invalid. Gonna do invalid in state.posix. There's another way that we can get out of this, so I'm just gonna go ahead and put that in as well. All right, then simgr.explore, find success, avoid failure, and if simgr.found, else raise exception, did not find solution. Then we want to go ahead and say print simgr.found 0.posix.dumps file dot decode. Okay. Oh, okay. Don't decode it then. Let's just see what it looks like. Otherwise, we'll write it to a file. Okay. Is the XFF necessary? Because this seems like a flag, right? Yeah, I don't know why we had that fgets. Maybe it simply skips that first byte of the input. But I mean, we didn't provide it in this case, so I don't know what the deal is with that. But it went ahead and found us the flag real quick. Didn't make the same mistake as I did last time with creating the angr, so this went real fast. And I'm feeling like all the practice that I did on Monday and earlier on this stream is really paying off, because these challenges are right in the use case of angr. Yeah, I don't know. It does stuff, right? And this is certainly the approach that I would use if I hadn't learned about angr, basically. I would be doing a bunch of manual reversing and then trying to recreate that algorithm in Python or create it as a Z3 kind of solver thing. Yeah, but just it's so much more manual, and you like this probably would have taken me a couple of hours, or I don't know, depending on how fresh on my reversing I was, might have taken an hour or something rather than 5 minutes, 10 minutes, whatever it is. Like, so that's what makes angr one of the most impressive tools that I've seen, frankly. I mean, I'd heard a lot of good stuff about it and assumed it was good stuff, but having an understanding of it now really both makes it more impressive and sort of solidifies that it's not magic, basically. Like, I could reasonably describe what the structure of angr is probably in terms of its internals. I wouldn't, I don't know all the details. I wouldn't be able to necessarily create it myself, even a kind of shitty version. But how you go from Z3 to angr makes sense to me, I guess. And because I understand the scope of what that is, I'm more impressed by the fact that people did all of that, and that it works as well as it does. Like, yeah, it's arguably more impressive to me than any of the disassembler tools that I've worked with, which are complicated programs and have very complicated algorithms to achieve the high quality results that they do. But angr is like, you've taken a tool that is this raw material of doing a very difficult thing. I have, like, Z3 is the part that I would say I have zero clue how somebody would implement that and how that system works. That's more of the advanced math kind of stuff than I'm experienced enough with to be able to really grapple with. But taking that basis, understanding it as a tool that you can use, and then building this whole system to sort of automatically use that tool and make it programmatically drivable in this way is like, I'm, just as a software developer, I guess I'm really impressed and appreciative of the work that people have done to make it. And I hope, I guess, that I can keep using it enough to the point where I can see things that I would like it to be able to do, and then maybe I can contribute in some way to help help the project expand and grow. Yeah, I don't know. I'm just sort of like very much happy with the fact that I decided to take the time to learn angr, because it's hard for me to see not trying to apply this tool in most all of my like CTF challenge work going forward. Even beyond this category, I think I'm going to try it for some of the ROP stuff, see if I can find those kinds of situations. It might not work for the heap exploitation. There might be too much state explosion, so to speak, to find when you can get the right corruption from that, but I'll give it a shot. At least, maybe I'll solve it manually and then try to solve it with angr, because I think it would probably be, it doesn't necessarily make it easier for me to solve a challenge that I don't know how to solve manually. But if I know the mechanics and I know how to solve it manually, I might be able to use angr to automate some of the process of solving it. And then, I mean, it just feels like this is a thing that maybe could really supercharge some of my work in binary exploitation. Let's see. And certainly for these particular challenges, like the fact that they're intended for the sort of reversing stuff, like it just, obviously we just saw angr makes it effectively not a challenge anymore, which I'm okay with, to be honest. Because reversing a very tedious manipulation algorithm is not necessarily the fun part of reversing for me. It's more about coming to an understanding of the whole scope of what the program is supposed to do and that kind of thing, and like the structures involved and what the intention behind the creation of the program was, and maybe some understanding of like how the tools involved in the creation result in the code that we have, like the compiler works this way and the linker works this way, that kind of thing. But like, oh, somebody wrote a bunch of bit shifting and bit twiddling logic to effectively hash your input, and then you need to compare that hash result against this hard-coded hash value or something. Like, reversing their custom hash algorithm actually doesn't, it might be necessary in some cases, but it's not deeply interesting work. It's more on the tedious side of things. Okay, so the next one called Future from Tuctf. I don't know what that stands for. And I don't know what year it is, but Tuctf Future is a 32-bit binary. It's dynamically linked, not stripped. That's nice. Linked with C, and see about, it's got no canaries, so I mean maybe it's exploitable with ROP or something, if it leaks a value, because it's got PIE enabled. So let's go ahead and run it. Okay, so my guess is it's still just a reversing challenge. So oops, it's just Future. Let's see if we can very quickly determine. It's going to take standard in, so that'll be our symbolic input vector. And what do we put if stuff is correct? Yup, that's the flag, I guess. Oops. Let's see if we can print that real quick. Okay, so we'll go ahead and make sure to include that and try harder as well. Should just try harder with a period. Okay. And let's see, project. And see if we can get that working. No, okay. Interesting. So I didn't find one that took us to printing out that string. But they do look like they're probably, this is presumably the success one? Yeah. Oh, maybe this is the, let me see. Gotcha. So we have to have it be equal to, what is that? 25? Oh, and I didn't put the returns, so that's probably part of it. Let's look at this one as well. Let's see, other failure message. We can try that. It doesn't feel like that would be a flag, though, to be honest. Let's go ahead and print that to a file. Solution. then cat solution to future. Okay, that was the flag apparently, or something that works with the flag. Let's see if, yeah, I'm gonna real quick look through this. They had something else. Right. So yeah, we also found another unintended solution. So this is a case where we could additionally do a constraint that I just don't know. Oops. This is under like the file system stuff again. So trying to see if I can get to a point where I can constrain that sim file. We know the length is going to be 25 characters. So let's go ahead and say standard in is product of factory dot. How do we create a sim file? Just maybe angr.sim file. Oops. How can we set the length of it? Size, right? Okay. So can we do angr.storage file.sim file flag is clarify.bvv, so bvs flag, and it's going to be 25 by 8, or let's do it as 19 by 8. Then content is equal to flag, size is equal to 19 bytes, I guess, right? Let's do that. Probably don't even need the size specified, but that's fine. Let's go ahead and set these up here. And when we create the state, we'll say standard in equals standard in file. I guess we technically can just still call it standard in. So then let's further say solution dot add constraint. Oh, this is where we want to do scaffold 17. What did we have here? Okay. Four byte in solution, or rather in standard in dot all bytes, and then what do we want the start of our bytes to be? Let's do greater than or equal to 21 hex, sorry, 20 hex, less than or equal to 7E. Oh, and I guess I don't, let's see, if I go to clarify, actually, we have a, why is clarify, what, okay, we look for bit vector, bits, maybe? Okay, we can chop. Okay, so why don't we do just standard in, sorry, flag.chop bits equals 8. For each byte in there, we'll add the constraint, and then we will do solution.solver.eval flag cast 2 equals bytes, decode that. Not store, but storage. Found another one. Okay, Jesus Christ, there's too many solutions to this challenge. So I was like, well, let me do it as something that's printable, right? So I think if we echo that to future, it's like, yeah, that is a flag. Okay, so if we add a constraint that it be let's see. How do we do an or with clarify? I'm like spending time trying to supposedly properly solve this challenge by making this stuff more complicated. Not fp add. It's got to be like, what? Am I going the wrong direction now? Bool? What do I have for bool? No. Can I just find me the document, like the high level documentation for clarify? I want greater than. Just annoying. That there's not like. Here we go. Show me the stuff that I can do. How do I compose things? Or clarify.or. Okay. So clarify or can I add multiple, or is it just two? Probably just two. Then byte is equal to whatever that is. Or byte is equal to whatever that is. I mean, this is like some of the ugliest code. I guess I can put it up here. And byte greater than or equal to just be, rather than switch suddenly into hexadecimal. Probably enough. Okay. This is really like I'm writing Python in Lisp style, and it's not necessarily I mean, it's definitely bad looking Python. Okay, so I'm just constraining it to alphanumeric underscore and then curly's, sort of a very generic regular expression, kind of constraint. That'd be interesting. I wonder if there is such a... Jesus fucking Christ. I just wanted to come out with this. Oh, and it needs the exclamation point. Great, okay. See, like... missing the final paren, of course. And finds a different one. Like, is it going to find a different random one every time? Wow. There's just too much that fits that particular. So what we could say is flag start is flag dot -1 to negative, how many characters? So let's do like flag start is equal to tuctf open curly when flag start times -8 equals flag start solution dot add constraints. So we'll add that constraint, flag end, and we can just flag length needs to be 25, and this is 1, 2, 3, 4, 5, 6. So 25 minus 7 is 18. It's the inner part, I guess. -1, negative, so we actually want flag right? It starts at 17 bytes in. So if we do negative flag end bit to negative flag end bit -8 equal to that number. And let's see if we don't need to add these constraints anymore. if that'll work. Got an unset result. Can we simply start the thing off that way? I got an invalid, can't decode it, huh? Okay, so let's add these back on. I think we'll just like leave the curly off because I feel like but we'll keep it like that, and it'll just be flag negative or len flag start times -8 onwards to 0. And then we've taken off 2, I think. Yeah. Okay. So close. I mean, it's like completely unnecessary, right? But then we can also say solution.add constraints flag from 8 to 0, or 7 to 0 rather, is equal to ord that. All right. With enough really forcing it in there, we were able to get the real flag out of it, which was much harder than actually just getting a solution that printed good job or whatever it was. But I like the little extra challenge of trying to construct a constraint properly. It would be very interesting to know I wonder if you could compile a regular expression to a like structure of clarify constraints. Because realistically, I should be able to write a regular expression, a relatively simple one. And I don't see anything. I think that's a question to ask in the angr Discord. And just go to the angr Slack because I think I already have an account. That's not the valid one though. This is the valid one. Let me see if it's mentioned in the docs here. No, okay. So let me sign in. I should definitely disable style overrides for this. Maybe Turn on dark mode. Just Jesus Christ, they're persistent. Okay. Just ask in general, I guess. Or maybe just in help. All right, we'll see if anybody has any thoughts on that. I see Fish is in here, and he's one of the main developers on it, so he might have some interesting thoughts. Cool. So another one that was solved pretty much instantly for some value of instantly. If I was actually doing the CTF live and I wanted to submit the flag into the system, I would need to have put those constraints on, or do what was mentioned in the write-up where I show, hey, this is a valid solution, and then hope that the admin takes pity on me and goes, yeah, we'll count that, here's your points. But if they said, no, you got to find the real flag, then, you know, it's on me to spend time in the constraint solving business. All right, Def Camp, which is Def Camp 2015 quals, R100. Just moving right along. Might be able to get through the rest of these in the remainder of the time. We've got 3 more, and if they don't get too much more involved, then we're definitely getting through them, I'd say. I guess I shouldn't jinx myself on that. Why does it not have these? Oh, now they're in 13. Okay. 13-angr. Okay. Really improving my computing skills right now. 100. It's a 64-bit dynamically linked and stripped. Linked with C and no PIE, Canary, NX. Again, almost certainly not a exploit challenge. Yeah. Is the password? It is not. Okay. Then we'll have to go ahead and take a look at it in Radar. Okay, nice and incorrect password. And I'm curious about this code path. fgets returns 0. Or, returns S on success or null on error. I see. Okay. So then we load that into Rex, because that was the address that we put in anyways. So we are reading in 255 bytes, looks like. Presumably the whole flag is not 255 bytes. But I don't think we need to worry about that. So and yeah, I could certainly branch.factory.simger. I could take some time and like create a script that does a lot of this setup automatically, or even just copy my old ones. But yeah, I don't know. I'm having an okay time of it, writing it all out each time for right now. Be incorrect password. Then see if we get it. Code talkers, and then it doesn't really matter what else we put in, I'm assuming. No. Interesting. Oh, I wrote it wrong. Yep. Yeah. Okay. Cool. That works for me. And it is code talkers. So, okay, this is the first one where I actually use angr to do something with it. It reads at most 255 bytes. Okay. Apologies. Okay, they went the route of like finding a particular address and avoiding a particular address. I think that's perfectly fine. In fact, it's a little bit faster to do it that route. I think they copied from another script, the Fairlight one, just because they've still got that in the args. Yeah, I mean, they found the same deal, right? And like we could probably write ours a little slightly faster by putting dump 0. We don't have to say sys.standardin.file number or anything like that. Cool. Okay. Let's do I can count from Plaid CTF 2019. This is still in 13 angr. Okay. Plaid and I can count. It's 32 bits, dynamically linked, not stripped. Linked with C. And no canary, but NX and PIE and partial row. All right. Then let's go ahead and run it. Are you ready? Go. Okay. No, the correct number is 1, but I believe in you. Let's try again sometime. We're going to count numbers starting from 1 and counting all the way up to the flag. Okay. Okay. This is an interesting one. So, again, we still just want to... It is interesting. We don't know what the flag is gonna be. I'm assuming. Increment flag. So, what are our exit conditions? This does a printf to what string? That's kind of annoying. Okay. So how do we want to phrase this? What does the check flag function look like? Okay, so if we get down to here, this is probably the success case. So and we want to know what our input was. I guess. Let's go with where's the check flag? Oh, sim.checkFlag. Can't print that. PFL. I thought it was PFL to print a flag value. or sorry, list of function. No. Jesus Christ. It's P to rent to. Okay. I don't know how I forgot about that. So we want to just do that address, I guess. And okay, so then angr dot this exit is the bad exit. So we'll explore. Then we can go ahead and write the solution input to a file. And we can also just print out yeah, we'll print out all of the output as well. And oh, I didn't import angr by sys. And we'll go ahead and just get the tail of that. I don't particularly care about all of this stuff. We'll see how long it takes angr to do this. Might throw veritesting on there. go on the angr. I don't know if that's going to help at all. Just feels like these should merge together. It might be necessary to manually make sure to merge stuff together. Like if we get to this state, then merge everything. I don't really understand the merging behavior. Yeah, just use PyPy. That's a good idea. Okay. So this one might be one to come back to when I have a better understanding of how to do optimizations and stuff. But I do feel like, I don't know, merging those states makes sense to me. I wish they had a page on Veritesting. They're just does this make it more involved? Yeah, I don't even know. So far, this is one that angr doesn't know how to solve very quickly, which is understandable. I would imagine that, you know, maybe they have created this with the intention that it be difficult for angr to solve. Yeah, I mean, we can look at the binary and see what it says. about how it does its thing. Let's see. Is this the code that does the flag check, I guess? So I mean, it might also be a case where I don't need to run the whole thing. I can start in here and what is ESI? Okay, so it's a fixed address from yeah, I think this one I'll come back to on the next stream. Where was it at? Text IO wrapper. Is it in solving? It's still in explore, it looks like. So eventually came down to C3 core. Okay. I mean, it doesn't help a great deal that we're also running this primarily in Python. I assume Z3 is actually, the fundamentals are implemented in C, but there's a lot of Python code going on as well. So, okay, I'm gonna set this one aside, but we'll come back to it on the next stream. I just imagine that it's going to take a fair bit of time, and I want to see if this one is easier. So I might end up dedicating all of the Friday stream to working on that Plaid CTF one. But I mean, we've got a couple of different possibilities for how to approach it. I think how to approach optimizing it or whatever. Nightmare modules 13, security fest, Fairlight, 64-bit dynamically linked, not stripped. Okay. Linked with libc and okay, no PIE, NX, and Canary are enabled, and partial railroad. That all makes sense. Okay, so it's another one where we pass in the argument. And if we don't pass enough arguments, we get that output. And then we check the string length, and we get no access denied. Oops. That's what I meant. If the length is not 14, and again, otherwise we can get to OK dash. Let's see. Let's look at one of these. Does this end up can called access denied? Okay. But I think what is interesting is we don't have like control flow out of this. So like, what's going on? Why would it not always print? Yeah, I don't know. It just seems like if we're calling these and they don't end up, does access denied exit? Oh, it does. Okay, I see. So let's just do a void address, I guess. And then 14 times 8. Or, okay. Then do this. Okay. Okay, solution.solver.eval flag cast to equals bytes. All right, and then a good exit is getting to 401 A91. All right, that looks okay to me. And then we will eval what the flag is. Anger management. Okay, so that was the correct flag, I'm pretty sure. I feel okay about that. Same deal. I mean, we could have had it printed out, I guess, but yeah, that was the input that we needed to provide. And their script, you know, basically the same structure. I guess we could try, this will be another thing to try with the def camp, or not def camp, the plaid CTF one. This guy that angr didn't solve almost instantly. So need to think a little bit more about how to go through that, basically. And maybe I'll read about Veritesting. I'll certainly be looking at the repo from this guy that sort of automates some stuff with angr for doing ponables, I think. Yeah. So lots of good stuff to research related to angr, and I'm excited to keep using it and keep trying out how I can expand on using it just from reversing challenges. But certainly, unless the reversing challenge was written with angr in mind, it seems like written to specifically to make it difficult for angr to automatically get through with the very simple configuration. Except with that, if they haven't done that, then angr seems to just chew through those things in like a matter of minutes, including the time it takes to write the whole script, which if I was planning on doing a CTF and I thought they might have relatively simple reversing challenges like that, then I would most certainly create a little template or create a library that I could use to just like very quickly do all of the boilerplate that I typed in like 3 or 4 times right now. So overall, very much liking angr. Want to see if I can keep using it in helping me with some of these. It sort of depends on how simple the actual vulnerability discovery process is in these. If they are very obvious vulnerabilities, like the whole main function is basically just a call to gets or something, then there's not a lot of point to writing up some stuff with angr. I might try using the Chris Roberts Zera tool, because I mean, if it's basically automated anyways, like it doesn't hurt to just give it a shot running it. But yeah, I would imagine most of these ROP ones, really the challenge is in the how to come up with the right ROP chain to do what you need it to do, I guess. So that'll be interesting. And I did remember seeing something that angr has a tool that can be used to find ROP gadgets at least, and maybe it could be integrated in some way with an automated script for using angr. But we'll find that out. I don't know if we'll end up even getting to the ROP stuff on Friday when we come back to hacking practice. It might turn out that the I can count challenge is going to be difficult enough to take up the whole 3 hours and potentially more, but hopefully not. I didn't really spend much time on it this stream, so I'm not gonna assume that it's gonna be an incredibly difficult challenge. I think it's just a matter of learning how to massage angr into the right configuration for chunking through that code quickly and avoiding like having to manage too many states and stuff. So tomorrow, however, on Thursday, right, it's going to be Thursday tomorrow, yeah, we'll be back to the x86 decoder. Going to be working on the decoding the SIB byte, and then we can add a couple more instruction variants into our set of working like instructions that get decoded. And I suspect that'll only take maybe an hour at most, and then we will move on to how we can start structuring some of the opcode decoding stage to be able to decode a few more opcodes, another whole set of categories. So maybe a little refactoring will happen as well. And with that all, eventually I'll start working on prefix bytes and stuff and get the 2 and 3 byte, or at least some 2 byte instructions in. I'd imagine all the 3 byte instructions are like the sort that I don't want to tackle right now. If they are like SIMD instructions or something, I'm not going to worry about it at the moment. I'd have to potentially significantly change up my output data structure to be able to support that, so I don't want to worry about it in this moment. But yeah, that's everything for this stream. Thank you if you're watching, and thank you if you're watching the VOD. I will be back tomorrow with more stuff. I'm going to end the stream now. OBS is probably going to die when I click over to it, so if this ends very suddenly, then you'll know that's what happened.